So now that we have a small function that renames a mesh, I wonder how we could make that function into a reusable tool that we can use in the 3D viewport without actually having to run a Python script. To do that, we might want to mimic the way tools work in Blender in general. Those tools are called operators, and basically they operate under context. For instance, if I select or an object, it becomes the active object, and if I hit tab or go into edit mode, the operator runs on that particular object. So the operator runs on the active object. Even as I pull the 3D header down, you can see that it doesn't actually say, oh, I'm going to run on the active object. It just grabs the context when it runs. So bpy.ops, this is the operators, and this is the object operators, edit mode toggle, just gets whatever active object you have from the context, so it knows which particular object to toggle. And you can actually do that here just by typing out the same operator, and it toggles edit mode, and run it again, and we're back in object mode. And you notice that it spits out a value down at the bottom here. So first of all, how do we get that value returned to us here, right? So when I do from rename import rename.py, oops, sorry, import rename selected. There we go. And I do rename selected, and I'll give it a name test. Notice nothing gets printed back here, right? And if you look at the way our function is defined, that should be kind of obvious, right? It just changes the name of the object. There's nothing else happening. So how do you actually get a function to sort of return a value back, right? And so that's pretty easy to do. That's done with something called a return statement. So the next thing that functions can do, other than do something, is that they can return a value. And we've seen that before, for instance, when we did sign of a number and we got the sign of that number back, right? So we can do that again here, or if we ran random, we got a random number back. So how do you return make a function that returns something? So let's write a trivial one, right? Def, so this is defining a function, and then call it echo back, and this is just going to echo back whatever you get, so x. So that will just take a value in, and it's just going to echo it back. So I'm going to write return x. This is a perfectly valid function. So if I write echo back test, I get back test. Echo back hey, and so on and so forth, and I can send it a number, like an integer for instance, and so on and so forth, and that all works. So all this does is it gives the value back to the caller. So I can also write something like this: a equals echo back 121. Okay, that's fine. And if I type a, it's got the value 21 in it. So this is a very trivial kind of example, but at least that's introduced to us a new element, which is this return statement. So that happens inside a function, and it causes the function to exit and return a value to the caller of the function. So that's kind of useful. And that's probably, we can guess somehow, how we're getting this finished back from our operator. Now we need to get a finish back from the operator because Blender insists on it. If you don't get it back, it considers that to be an error because it doesn't know that the operator finished. So that is another thing that we can add to our functions. Another thing that we can add is some documentation, right? So you can say, it would be nice to be able to write a little comment in your file to help you know what it's doing. So you can write something like several ways to do documentation. For instance, after the function define, you can put a triple quoted string, like so, and you can use single quotes or double quotes here, and you can type out rename selected object to x, string x, for instance, right? That's called a doc string in this case when it's right after a function call. And you can say, after here, for instance, we can add an inline comment, which is just with a pound key, where you write change the object name. For instance, that's a comment. So this is a nice way to document your code, is to write comments, especially where you have something that you have a hard time understanding, or it might need explaining a little bit. So we have commenting and returns. And the final thing is to think of an if statement. So sometimes you want to run things conditionally. You don't want to have them happen all the time. And the way to do that is to use an if statement. So if is testing the truth or false of something. So let's say you want to say, so let's have a look at this guy. So you can say if type, or if you can do this. So if context, so just use the C convenience variable here. If c.object.type equals to mesh colon print it's a mesh. Oh, actually, it's a mesh. So I had to use a double quote since I'm using a single quote inside the string. So, right? So basically, the active object is a mesh. So this equals operator is like, is it equal to? So, and that returns a true or a false. So I can also type, just to test that out. And that's true. Now, if, for instance, I add let's add an empty, and try running this again, and we get a false. And if you run our if statement again, I can now do this. I can do else print c.object.type. So this is an else statement, and it's actually an empty. So let's have a look at this. So first you have the if statement, and then you have a condition that has to evaluate to something that can be interpreted as true or false, right? So you can also write if true, and that will also always evaluate to true. So the true or false are booleans, and they're written with a capital T and a capital F, followed by a colon. And like every case where you have a colon, like define or a for loop, the next, everything that's within that scope has to be indented in. So we have an indented block where we do stuff that happens only if the condition is true. Here we just printed that it's a mesh. And then we optionally can write an else statement at the same level of indentation as the if, also with a colon. And here we can write some specific code that only runs if the condition is false. So that's an if-then statement. So the final bit of theoretical concept that I'm going to introduce in this section before we go on to writing our tool is the concept of a class. So if we can imagine that I am a person, so I'm of a class human, I can define a class So let's say class human, like so. And I'm going to, by convention, we'll just start it with a capital H to indicate that it's a class of things. So now I'm inside the class human, and I can write something like define a function that is something that a human being does. So I can write def, and we'll do eat. And here's a first special bit of notation that we'll show. I'm going to write the word self. I won't explain it here, but it's just to say briefly that it refers to a member of this, the actual thing that it's eating, the object of the class. And then here I'm going to write foodstuff as an argument, colon. And I'm just going to say print I'm eating, comma, foodstuff. Right? So this is my very, very simple class. So now that it's done, I can write Bassam equals to human. And what that does is that it actually creates a human object. So if I do type Bassam, you can see that it is a human type object. The underscore main refers to the fact that it's defined in the same context that we're running right now. We're running inside the thing where it's defined right here. So now I can say Bassam.eat. And this is where that self comes in. Self is like a dummy argument that actually refers to the owner of eating. So I have added eating as a thing, as a method in this class that all class things can eat. And I have to give it a food to eat. So I'm going to eat a French fry. Well, let's make it plural, just to make it nicer. And it says that I'm eating French fries, which I'm not. But anyway, that's a really trivial way to define a class. So class can have, so Bassam is an object, and it's a member of a class. And actually everything in Python is a member of a class. Like if you do type 30, you can see that it's an object of class int, and it has attributes as being a member of that class. You can specify class attributes as well as class methods. So if I say a equals to 30, we need this for syntactical reasons. I can do a dot bit length, and it's just a function. I don't even know what this function is supposed to do. It's number of bits necessary to represent the number in binary. So this would take 5 bits to represent the number 30 in binary, which makes sense since 32 is 2 to the power of 5. So in any case, so even an integer is actually an object that belongs to a class, and that's actually true of everything in Python. So everything is basically an object. And we'll see next that when we go to define ourselves an operator, we have to create a class for it. And that's the way that Blender will know to use that operator in the next section.